Hello guys, welcome back. In the last video we managed to get the day 6 done. In this video we'll continue with the day 7. So let's get started. And here, yes. So day 7, bridge repair. The historians take you to the familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it will take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations. And this will be our puzzle input. Okay, it looks like that. So each line represents a single equation. The test value appears before the colon on each line, so it will be example this one. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Operators are always evaluated left to right, not according to precedence rules. Okay. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see elephants holding two different types of operators, add and multiply. Okay. Only 3 of the above equations can be made true by inserting operators. Okay, yeah, this is multiply. Then you just need the total calibration result, which is the sum of the test values from just equations. That could possibly be true. Okay. In the above example, the sum of test values for the 3 equations listed above is 3749. Okay. And let's get our puzzle input. Looks good. And let's put it in here. Yes, and I think we can do the regular splitting already with the line change. If we execute this one and wait for the runtime allocation, we should get it up and running soon. Yes, we have. And we can then check check that how it is looking. Yes, looks good. How to split this up? I was now started to think that since in the last video, or not last, but one of the videos earlier, we had some issues with not using data classes. Recall there was some mix up with the values. So for this, I was thinking that maybe it's better to utilize these, since we have a lot of different kind of values. So let's again, data classes was in, yes, data classes. And what could be good? Input row, like for name, but we can start with that. So what we have here, we had the test value and then the values. Okay. Test value, which is integer. And then values, which is list of integers. Yes. And I think that is the simplest data class we need for now, at least. Let's populate that one. So for row in input, we want to split it up so that we have the test value, and then the values. In this case, it would be row split. If we split it from this point, we have then the test values in here and then, or test value in here and then the values here. Nice. Actually, we need to have also input rows, which is an array to gather all the created instances. So we could now just input the append, and we want to create input row. And for that, we want to give the test value and then values. Yes. But before we can do that, we want to cast this test value to be integer, since it's currently in string format, and the values as well. So we could just loop them through. Like this. So we loop them through, cast to integer, and then the new list. And actually, we need to also, before this, we need to also split it by space, because every value is separated by space. And actually, we need to figure or handle the first space as well. So what we could do is just split from double colon and space so that we have the test number and then rest of the numbers nicely, and then we just cast it to values, and then we should have all the values in the values list in integers. Now if we check the input rows or contents of input rows, we can see that we have the values and test value as they should be. So now we have kind of the data ready. So what we should do, so we need to kind of generate all the permutations of these, or combinations of these numbers with add and multiply. Okay. And then when we have those, we need to make some custom logic to calculate the results. Okay, let's then maybe store them here combinations list. These are list of integer lists like this. I think this could be the way. Yes. I meant to add that in. Now we should have test value values and combinations. Looks good. And now to make the combinations, since we have kind of this tree structure that we need to have combinations of everything, maybe we could use recursion for that, because then we have in each recursion step we have the context kind of existing, that what we had and then what we will need to do, and then also like we can split it up since we have two options, plus and multiply. Every time we call the recursion, we need to kind of split the branch up. So we need to add operand maybe, and this is operand and then handlet numbers. So this I'm kind of thinking that we give to this function we give the operation which is plus or multiply. Then we have a list that contains already the numbers, previous numbers, and the operands, and then the unhandled numbers. Numbers, so which is basically the rest of the list. And here we want to check that width length of number unhandled number. Unhandled numbers is 0. So then we know that we are in the end of the loop, and I think actually we need to have the input row here as well, so that we can then, or let's have it for now at least. Let's think later on. And then input row dot combinations dot append handled numbers. I think this could work. Then else, if we are still in the middle of the process, what we want to do is to get the current number from the unhandled numbers. We can just poke the first one, and then if basically what we want to do is we want to handle numbers as the operand to the handled numbers, and then after that we want to current number. So this way I was kind of thinking that we would build a list with these numbers, and between the numbers we would have the operands. And then after all of that we will start we will start the recursion process. So basically handled numbers are now the updated list. And same goes with unhandled numbers. Since we popped the one item out, this was in place operation, so the existing variable got updated, and then we just pass the input row forward. And we want to do the same for the multiply. So every time we do operation, we will then make sure that we have the both plus and multiply cases handled. And now, so if we would call this now for input of item in input rows, so basically we would call it actually, so that kind of we would maybe have it a bit cleaner. I was thinking that, what if in the first iteration we give the operand as none, so you need to only call this once. Then handled numbers is of course empty list. Unhandled numbers is item dot values, and then the input row is item itself. But to support this, we need to check here that there, but it is in here, because what it basically means, if its operand is none, if operand is none, it means that we are currently in the first place, or handling the first value, so there is no items in the handled numbers before that, so we just add the first number in the list, so that the flow then gets better. And let's review this a bit. So since this is recursive, I'm kinda actually wondering that since we pass the same lists around, will we have some issues that we would kinda shadow, or kinda, since I know that how Python works is that it updates if you modify certain type of variables, the change may kind of leak into the other iterations as well, and especially this recursion is something that I'm kind of slightly afraid that will happen. So to mitigate that, we could use copy. And I think with that, it's not the best memory-wise. It will use a lot of memory since it copies the variables around, but for this, I think it's okay. But it's more like if you use it in the production code or something like that, you should be aware that this kind of behavior exists. So first, you want to copy the handled numbers. So each iteration will have their kind of own copy. And then unhandled numbers. And then we will have a copy as well. Handled numbers. And then we just pass the copy forward, and same with Same with unhandled numbers. Yes. And input row is something that we don't need to take care. And let's actually try to run this. Was there some easy rows? Or maybe we could just divide a seed in action and kind of so that we can validate that it works. We could just copy this example code. Example code, or like this example input. From here we can then run it. Then we should replace input test. And now we should have not enough values to unpack. One. Oh, yes. We forgot to split it. Now, yes, it works very well. And then if we double check the input rows, we should have quite nice list. Yes, correct. And then we should be able to already run this. It's nice how long it takes already for this amount of rows. But let's see. Now I'm thinking that it's in some like loop, indefinite loop. Okay, won't stop. Maybe reload. Reload will help. Okay. So let's then limit this to be just, so if we just take the first item here, and then we'll call this like that, and then let's try add some prints here. We shouldn't have like, we should have handled numbers increasing. I think we name input rows is not defined. Ah, yes. And we now need to run this again, and then this, and then if we run this. Okay. Maximum recursion depth exceeded while calling a Python object. Okay, so we need to modify this a bit. We want to return this here, and then we want to basically, or I think the issue was exactly this line. So results, if it's empty, and then we first just append this, and then return results, and then here we do results and append whatever we got from here, and then same happens to this, and then we return results. Yes, and then we don't need to pass this in, but instead item dot combinations. So now we should have a list of results. Before actually doing that, let's actually print what we got from there. So we got none, 10, and 19. And maybe print the item as well. So combinations none, 10, and 19. Okay, so none was part. Why it's none? So type, it's not none. Yes. Now we got it. So we have quite actually let's remove that one. So we have quite many. We need to actually rerun this, and this, yes. So now we have it empty. So what we can see is that we have quite many lists, and there is multiplication happening. So what if we test with the second one, with that third, three values in the list? So we will have okay, this looks relatively okay. And did we have some flatten in Python? Okay, no. Let's Google actually a bit. Python list flatten lists flat. Okay, so we need to basically make our own handling for that case. So yes, this flattening seems to be a bit unnecessary complex operation. So I was thinking that since we know that result in the end is always a list of unhandled numbers, or handled numbers, sorry. So it's already list of lists, or list of list. So we could maybe just simplify this a bit. Not the plus, but like that one. So we will assign results to be the list of lists, and then we could just, instead of appending, we could just say that let's merge these lists. So what we would actually have now, we will have 81 plus 40 plus 27. Okay, not exactly what the I was thinking, but we need to do this, of course. Or we could actually simplify this even further and just do like this. Or like this. Split this also in the another row. Let's run it now. Okay, now it looks way better. So we have now list of lists. We have some duplicated lists, but that is in the sense fine. So now we could just set the item dot combinations like this. I think we should be quite good. Okay, now it executed fast. So what happened? So if we check the one input rows now, let's see what we have. So we have all the combinations here, as it should. So now we need to start figure out how we can calculate these. So basically, if we loop, or if we have the for item in input rows, we have the combinations. So we have another for loop. So we'll loop through the item combinations. And now we have the combination, which is this kind of list. And we could actually do helper function that calculate values, current value operation, and the number that we want to do the operation, number, and this will return current value if operation equals plus, then it will return sum of current value and number. And otherwise we already know that it's okay, there was no multiplication, but we can do that. That's current value and then number. And for this, to use this, we need to have always the current value and then operation and then the number. And for that, let's see, current value or value. We start with 0 and then current operation. We start with none, and then for item in combination. So we know now that if item did we get it like this? No. Item dot. How we can get type of Python get type of variable. Okay, so we can just use that. Let's actually confirm that it is working. Type like this. It's here. True. Okay, and then if we check with number, false. So if item type of item is integer and current operation is not none, then we can call value plus equals calculate value, and for this we will give the we will give the value. So since this will increment the value already, we will just replace the current value variable value, and operation is current operation, and then the item is the next one, and then elif type item is string, then we will update the current operation be the item, and then after this we should have the value. Let's just print the values. So if we get the first input row, and then check the combinations, we should get 4 values. Name calculate value is not defined. Yes, we should run that before. Int object is not iterable. Let's then do just this. And then, so we had 19, 19, 0 and 0, which are completely wrong. Because the combinations actually we could even do here current combination, set this to be none. So we got 4. I'm wondering a bit that current combination, example that one, then combination item 19. It will go here. Yes, I now know. Else. So if, or elif this, then we will just set the value to be the item. And then if it's that one, then now it should work. 29, 29, 190, 190. Yes, so we proved that it's working. And then what was the so we needed to sum of the test values which were correct. Okay, so oops. Yeah. Past test values. Let's use this list. Then if value equals to item dot test value, then we will append the current items test value to the list, and then we want to also continue the loop, or actually break. Now we should have only int object has no attribute. Oh, sorry. Input row. Yes, like this. Now, and then if we just check the past test values, it should have 190. Yes, correct. And then if we test with the whole test dataset, we should have quite many here. Then if we sum them up, like this, it's 3749. That's looking good. So what we now want to do is to try out with the original list or input. So now we should have input rows, quite many. Nice, wonderful. Then we can just run this just in case. And then this. And then this one. But let's actually do so that we enumerate this and then get the index. What I want to do with this is that we want to know, or we want to know which item we are handling currently, so we can see that is there a stuck situation or something like that. But before that, I want to see len of input rows. So 850. That's good. So we can start running this now. Okay, it's fast. And then what we will get from past test values. That looks good. And then if we will just sum them, quite big number. And let's try. What does it say? Yes, that's golden star. That was interesting task. And I think it's good to end here for this video so that it won't get too long. So thank you for watching, and see you guys in the next video. See you.